to my channel Bal Vigyan Bharti, and here is your mentor Avilash Sarkar. We have just finished the subject trigonometric ratios, and as I have told, I will move into some subjects of physics. Now this time this subject will be the extension of that kinematics, where I finish the uniform motion for any translatory motion. And now this time this is the extension of that. This chapter is called the instantaneous motion for mostly the translation motion. So this chapter says instantaneous motion. So now let me recapitulate the thing that I have taught you in for uniform motion. Uniform motion is all about the motion where there is constant velocity or constant acceleration. Okay, now what does it mean? It means that the constant velocity means that velocity is denoted by delta s or delta d, you can say, by delta t. What does it mean? For the s stands for the displacement, and d stands for the distance. So in any case, if a particle changing its position with a curvilinear path or a straight path, let's say it is changing its position from A to B, following whether the curvilinear path or a straight path or only is the curvilinear path. In that case, if I consider this case, the distance will be the path actually it is moving through to the next position, that means from A to B. So distance is the position change from A to B following actual path. Okay, following actual path, and the displacement is that time change in position in straight path from A to B. So whether I am not traveling in actual also from A to B, in case of displacement I will consider the straight path, means whatever way the position is being connected from in a straight line, that will be the displacement I know. For actually if it is moved in a straight path or during consideration or calculation I consider the straight distance, that will be the displacement. And with that, with the time, means if it is, let's say in time delta t is nothing but t2 minus t1, and whereas this is the finish to initial, this is also finish to initial, whatever be the case. Okay, this case is only d and this is d. So this is the final to initial position, and time also, this is final to initial. This is the time taken from, means if it is started at any point of time here, after certain time it is reaching here, that time difference will be the delta t here. So v is being calculated either by this, when v would I say velocity in case of delta s by delta t, that means I am considering displacement, and when it is only distance being considered, that I call the speed. So this is the only difference, but thing is that it is uniform. That means if I say the uniform velocity, that means change in velocity would be same. If I say that is in constant velocity also, that means the change in velocity, that means change in velocity is what? The further delta v by delta t is 0. That means change in velocity means this is nothing but the acceleration this acceleration is 0, that means uniform velocity, that means either the velocity is constant or the velocity if I consider s upon t and I represent a line, so that means in each equal time interval it is moving equal distance, then it is uniform velocity. Or as in case that this is velocity against time, if I represent, I am getting same velocity here, that is uniform velocity. Okay. Other case where acceleration is uniform, that means if I represent v upon t and represent with a straight line, that means with uniform in each same interval my velocity change is same. That means if I start at the 0, if I reach here v, if it started as v and I will reach at 2v, then 3v. So this change in velocity every time is same with the same segment of time. If I represent the v upon t, and if I represent the acceleration t, that will be constant acceleration. So this is the same representative here also. So for uniform velocity, something which is variable, which is dependent about time is constant. Either v is constant or acceleration constant. That means not variable. Now, the case where this is not constant, that means till it is constant, v or acceleration till it constant, we call it uniform velocity, uniform motion. Okay, where these things are constant, either v is constant or acceleration is constant, or their change is constant. That means change in v is constant, then we can say the acceleration is constant. Change in change in displacement with the time is constant, then velocity is constant. So these are uniform. In the extent of that, there could be some possibility that if I represent in a graph, let's say one motion is that with a certain time, let's say this is t interval, t1 interval, it is moving with the constant velocity v1, let's say. In some next interval of time t2, it is moving with the v2. Then this next instant of time, I'm not say instant, this is in a segment of time. This is at the time segment where that velocities are changing, but in that segment it is uniform, but that uniformity for the whole journey is not maintained. So that means I will not get. And one more thing, in uniform velocity, the slope of the curve is same. So as because it is straight line, it is not changes. So that if I say it is s upon t, so delta s by delta t, which is this is delta, you can say, for any instant of time. If I take this as a part of that journey, this is delta s, this is delta t. So this is constant. This is represented by the tan theta, the slope of the line. Or in case if I represent with v upon t, so then also the delta v by delta t, which is represented by the angle of this, that is the acceleration here, this is the velocity here. Okay, so these are constant. But in this case, if I say it started from 0, moving as a whole segment of journey, segment wise they are uniform, but as a whole this is not being maintained in a straight line. That means I cannot connect all these points with a straight line. So that means for each segment wise, that velocity for a whole journey, this is not a uniform velocity. That means for the whole journey it is non-uniform velocity. It could be possible. Now if I extend it such a way that I reduce the time frame, and that way the thing is changing frequently. or further I will reduce. So can you feel that if the time segment is small and within that velocity is constantly changing, so there could be one possibility that the representation of the motion can be done with a curvilinear path if in case the time frame is such small that within time frame that thing is changing. Okay, now if it is represented by velocity, and velocity with time, and every point of time it is changing, means I cannot even consider a time that is even countable, and within that delta v is changing, and it's changing so frequently, so this small line can be converted into a single curve. In that situation, this motion is called instantaneous. Why it is called instantaneous? Because if I consider any point, any 2 point very nearer, or let's say, let me take it little bit further initially, and this could be the case where change of v upon change of t being represented. But in that case, you can see this is not the straight line, it is a curvilinear line. So to get a straight line, if I further reduce, so when you take a straight curvilinear, more you go far, you will get straight line, a prominent straight line, but more you come nearer, that straight line will merge to a point. So if I reduce that change, if I want to bring those point, let's say this is AB, now the new position A dash B dash, in between the things will be more straighter. Okay, so more you come together, so there may be one such point where that the 2 points, when it is moved to so close, so these 2 points have no existence separately, rather you can say this is only a single point. But theoretically those are not the same point. So for instantaneous motion, my assumption is that the points which are represented change in position are so separated that they represented, or they resemble, you can say resemble a single point but not same. So this is the condition of a instantaneous motion. If I consider this motion in a graphical form, so those position, change in position is such that they resemble same point but not they resemble the single point but not the same. So in such case, we can consider that, and why that being so close, what is the thing being changed? This is the, you can say, the delta t each time, the span of delta t, for which I can get a span of delta v. More you reduce delta t, you will get the lesser value of delta v, and this slope will become straighter. And at point of time, if I consider this is not the separate point, this resemble the single point but they're not same, but with the thing, I can consider a tangent which is always a single point contact for any curve. I can consider, and that tangent at that point of time where it is touching the x-axis, here it is represented by x-axis, the theta, that could be the tangent to the to that point where I'm taking, and then that tangent will represent by reducing delta t. So more you reduce the delta t, more that delta v will reduce. So delta t can reaching towards 0. Can I say that? Because more, what would be the case practically possible when things being reduced, that can go to 0. Negative time doesn't mean anything. So more you reduce the time, it will be the time that will reach to 0. So I can say that delta t, when it is moving to 0, so delta v also same time will reduce some value, and that value will call delta v, and the respective delta t is called delta t. This is called the derivative. Okay. So in this is being considered in a form of mathematics that is called calculus, where this finitesimal means that so minute thing being considered in calculation, that is comes under the calculus, and this particular form is called the derivative. So this can be represented the limit. I am saying the limit for what? Limit for change in time. If it is reaching to 0, then delta v upon delta t, in case of the bigger case, what we will call, this is the slope of the motion curve, that can be represented as delta v by delta t. Okay. Now I have represented this curve in the form in the scale of t against v. No, sorry, v against t. V is this is dependent, this is independent. So time is always independent because time does not depend on anything, whereas other parameters which are variable depends on time, particularly in motion. So in that case, limiting condition is that the delta t, the change in time, when it is reaching to 0, more you close, more it reduce, and the ultimate can reach to 0, but not 0. The condition is delta t can never be 0, because then in that case there is no meaning of motion. It must change, but it is reaching to 0 but not equal to 0. This is the prime condition. This is under quote. You cannot, has to understand. So the limit condition is the delta t reaching to 0. That means delta v also particularly, which is dependent on delta t, will reduce, and that form is represented by the derivative. This is called the first derivative of anything. First derivative of v in this case with t. Okay. Now you understand. So this is called instantaneous, where the point of change in position is resembled or seems to be single but not the same. Okay. So this is when it is represented by. So in case I represent it with the displacement upon time, the same thing here, this thing will be represented by delta s, and here the limit delta t is moving to 0, means changing to 0, where delta s by delta t is represented by delta s by delta t. Now in earlier motion, what is this being called? When displacement upon time, the change in displacement upon time, that way the same thing will be represented by velocity here. In case it is displacement, we may call it instantaneous. We can symbol it, or otherwise we can say it is v. For understanding, I am writing as I. This is instantaneous velocity for any displacement, that is delta s by delta t, and this is called the acceleration delta. So this is the first derivative of the delta s delta t will give you the instantaneous velocity, and first derivative of velocity will represent by dv by dt. Now as dv further can be written as this v is a function of s, so then further I can do derivative of delta S delta t, and the result will give you, can be represented as ds2 d2s by dt2. This is the second derivative of this. Now any the motion equation, the displacement, if it is a function of t, only then I can do the derivative with respect to t, because only then it will come. Otherwise I will have to make some other changes that can be explained when I will do the mathematical problem solving session for this. So but as of now, the displacement must be a function of t, then only I can do derivative and can get the velocity. So if it is so, this can be represented as ds by dt. If I do the derivative, so this is the function of whatever function being given with respect to t, that has to be derivative. Now for example, if I say the displacement equation is given as 2t square plus 3. So this is the time based representation. This is, you can understand, this is the function of t. Now to get the ds by d2, I have to do derivatives of ds by d2, and the same way I have to do derivative of, the lower class may not understand the derivative, but for the simple understanding I am just giving an example. If ds by d2 is, you have to calculate the velocity at instantaneous velocity at any point of time, and that you can say after the derivative I will get some function, that I will get some result which is again a time based. How? So any some rule I have to write it here. When I do derivative, d of a into b upon any, let's say, so this is dv dt plus dA dt. This is the case. Now in case a or b, let's say, is a constant, if it is a constant, then let's say I am taking a is a constant, so then the result will turn into a into dv dt, because derivative of with respect to anything of a constant is 0. So this part will be 0, and with the multiplication of b it will give you 0. So if anything is constant here, so that final result will come as this one. Okay, so now if the same concept I will use it here, I will get, see there are two parts, this part, and derivative of a plus b is the sum of derivative of the individual. Okay, so this way it can be separated. So you can see there is a combination of constant plus variable. This is only constant, so this part when I will do derivative will be 0, this part only will remain, and this will be t square. Now d dx upon x square will give you, or n you can say rather, any power of x to the power n by with the same independent variable. If I do derivative, the result will be n into x to the power n minus 1. Here 2 will come here, t to the power 2 minus 1. So ultimately 2 is there already. So 2 into 2, 4 into t. So now you see the velocity is the function of t. So you can say that velocity is variable. This is called instantaneous, means any point of time I will get a velocity here. When t constantly, I can say that t at 1, what is the velocity? So I will get a single velocity. At t 1 to 1.1, if I say, I will get different velocity. T 0.00001, then I will get a different velocity. So that means instantaneously velocity is changing. So your motion curve, if I say it is with respect to t, will be somewhat which is not a constant. At any point of time I will get a different value. So this is the concept of a instantaneous motion. Okay, so that instantaneous motion can be is a vector. This is also a vector, because whether magnitude changes or direction changes, this will be affected. It's not that a linear motion cannot be a linear motion. In every point of time velocity means when you will ride a bike, I constantly can increase acceleration, so it is constantly changing, whether even if I am moving in a straight line. So then also it is a part of a instantaneous velocity I will get, because every point of time I am putting some force that will change the motion against the friction. So there are so many forces acting, but in kinematics, as I told, I will not talk about the reason of the motion. So but in any case, the motion is changing due to some forces. So for instantaneous motion, whatever the reason it is changing, that is change is instantaneous. Okay. And if in case I am moving in a circular path with a constant speed, then also, as because it is changing constant direction, that also comes under instantaneous motion. Okay. So this is the overall concept of instantaneous motion, and I will do 2 or 3 sums so that the concept may be more clear, and then I will move into one more subject, that is the cross and dot product of 2 vectors, and then I will come to the mathematics segments again. Thank you.